Today we'll be talking about first degree equations and formulas. So first degree equations, it's good to just have some sort of examples in your head. So something like 2x plus 5 is equal to y, or y plus 4, something like that. It's just something that only uses combinations of constants and variables. So here we got like some constants going on here and then a couple of variables. So x and y would be your variables because these could represent any number at this point, and then like the 2, the 5, the 4, those are your constants. Each of these, the 2x, the 5, the y, the 4, you would call each of these terms of your first degree equation. And let me write another one over here. So let's maybe do like 5a minus 6b is equal to 12. On the left-hand side, we have a couple of variable terms. And on the right side, we just have a constant term. Okay. Yeah, so these first degree equations are not allowed to have any like exponents or square roots or trig functions or anything like that in there. If you do, it's no longer a first degree equation. So some examples, again, you could have something like 2s is equal to p plus y over 4, or you could have a equals 2b plus 5. But some non-examples would be maybe you do natural log of a is equal to 5y or something, or 5y squared. So the natural log makes it a non-example, and then having it be like a y squared makes it a non-example. You could have 5 is equal to like the square root of x plus 3. This is a non-example, or maybe I should put like a y on there. Yeah, but something that would be fine would be if you do like y is equal to x plus the square root of sine of 0 or something like that. So like this is fine because this is not really like you're allowed to have square roots and like sine or natural log or blah 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 whatever for like your constant terms, as long as it's just not being done to like your variable terms. So like you can't plug a into like the natural log function. You can't square a variable. You can't take a square root of a variable. You can do that stuff to a constant because that just gives you a different constant. Like if you were to evaluate the square root of sine of 0, that's just going to be a constant. Like this sine of 0 is equal to 0, so the square root of 0 is equal to 0. So this equation over here really is just the same as just like x is equal to y. Expressions, equations, and formulas are all strongly related things, and people usually use these words interchangeably, even though they actually mean different things. It's just sort of like people don't know what the words mean, so let's just briefly talk about it. An expression would be something like 2x squared plus 5y plus 8. It's just some combination of numbers and variables. There's not really any restrictions on it. An equation would be, well, let's take that expression and let's take a different expression. Let's say like c to the 4th minus 5. It really doesn't matter like what's on both sides of the equation. It's just you have an expression over here, you have an expression over here, and you're setting them equal to each other. That is an equation. Equations have to have an equal sign in them because you're setting one expression equal to another expression. A formula is not very different from an equation. So if I were to say that a is equal to pi times r squared, this is a formula for the area of a circle. But really, it's not any different from an equation. It's just like it's basically just an equation that relates quantities to each other. So the only difference between like a formula and equation in practice is that formulas are used to kind of how do I say, they're used to figure out some unknown using values of other unknowns. So like if you want to know the area of a circle and you know the radius, then you can plug in the value of the radius and then figure out the area. Maybe you have like a more complicated formula that involves like multiple variables in there, and you have to plug multiple variables into that formula to solve for the other one, but you're still, plugging in values to figure out another unknown quantity. On that note, when you're like trying to find that like unknown quantity, that's basically what it means to like solve an equation. So if I were to say like 2x plus 6 is equal to 10, then to solve this equation just means to find all of the values of your variables that make this equation true. And so in this case, the value of x equals 2 makes this equation true, because if I were to plug in 2 times x, and x is now 2, plus 6, that is equal to 4 plus 6, and 4 plus 6 is in fact equal to 10, which is our right hand side. So like this is our left hand side, LHS left hand side, RHS right hand side. So our left hand side, if I plug in x equals 2, is now equal to our right hand side, which is just 10. Right, so this shows that x equals 2 is a solution to this equation. But of course, in practice, like you're not just going to be told the answer, you're going to be asked to find the answer. And so if you were to solve this equation, what you would probably do is, well, you can start by subtracting 6 on both sides, and you get 2x is equal to 4. Then you divide by 2 on both sides, and then you get x is equal to 2. What we're really doing here is we're manipulating this equation. We're changing this equation into a new equation whose solutions are the same solutions as the previous equations. Like the solutions to the equation 2x is equal to 4 are the same solutions as the equation 2x plus 6 equals 10. There's, if x makes this equation true, then x is going to make this equation true, right? And you can see that by saying like, okay, well, if I take 2x equals 4 and 2x plus 6 equals 10, plugging x equals 2 into 2x equals 4 is like different fundamentally than plugging into 2x plus 6 is equal to 10. And even plugging into the equation x equals 2, like this is like still an equation that you can like plug into. It's just very obvious that if you plug 2 into this, then it's going to be true. Okay. So the general goal in solving these first degree equations is going to be to isolate the variable on one side of the equation. So this is kind of what we did over here, was we isolated x. And then we had like just a constant term on the right side. So we got x all by itself. First we had x just mostly by itself, just being multiplied by 2, but then we got rid of that 2. So we completely isolated that variable x. So you isolate that variable on one side of the equation, and then you should be able to say what it's equal to. Okay. So elaborating on what I kind of already said, we can start with one equation and change it to a new equation that has the same solutions as the previous one. So things that you could do are add and subtract the same thing to both sides, and multiply or divide both sides by the same non-zero number. So like for example, in 2x plus 6 equals 10, we can subtract both sides of the equation by 6, and we're getting an equation that is like still going to have the same solutions, and then we divide both sides by 2, and that is also going to have the same set of solutions. So these three equations all have the same set of solutions. They're all equivalent to each other. Right. All right, so let's solve this equation. Negative 2a minus 5 is equal to 4a minus 13. So first thing you might think to do is put all the constant terms on one side. So maybe let's just add 5 to both sides to get rid of this negative 5 over here. So just bring the negative 5 over to the right. We get negative 2a is equal to 4a. And then what's negative 13 plus 5? That's negative 8. Now we have a's on both sides of the equation. So let's maybe take the 4a from over here and subtract 4a on both sides. So bring the 4a over to the left. Negative 2a minus 4a is equal to negative 6a. Sometimes you'll have just like negatives on both sides of the equation. You could multiply both sides by negative 1 to deal with that if you want. So I'll just multiply both sides by negative 1. And now I want to isolate a completely, so I'll divide both sides by 6 and get that a is equal to 8 over 6. You could simplify this by canceling out a factor of 2 from the top and the bottom to get a is equal to 4/3. Let's solve this equation. 2x minus 5 over 6 is equal to 3x plus 8 over 4. A couple ways that you could go about doing these things. I'm just going to show you one way, maybe two. I'm not going to show you every way to solve one of these problems. Just know that there are a bunch of valid ways about going about doing these things. These are very flexible. One thing that you could do is just kind of cross multiply. So multiply both sides by 6 and then multiply both sides by 4. So I'm just going to copy this down over here to demonstrate what I'm going to do. So I'm going to start by I'm going to kind of explain like what you're really doing with cross multiplying, but if you just want to think of this in terms of cross multiplying, go ahead. But with cross multiplication, what you're really doing is multiplying by 6 on both sides just to clear out this denominator. So that cancels that out, and I'm just left with 2x minus 5 on the left. And then on the right, I'm multiplying everything by 6, so I have to distribute that to everything. So 6 times 3x is equal to 18x. 6 times 8 is equal to 48. This is all still being divided by 4. And now I'm going to multiply both sides by 4. It's good to kind of have parentheses when you're doing these things just to sort of hammer down the fact that you're distributing everything. So 4 times 2x minus 5 is equal to 8x minus 20. And then on the right, the 4 is canceled. Okay, now if you wanted to just cross multiply, just say like, okay, bring the 4 over here, bring the 6 over here. That's effectively doing the same thing. I'm just kind of taking the extra time to explain what's really going on there, just for instructional purposes. Okay, I'm next going to bring all the x terms to the left side, just because that's kind of what I feel like doing. So I'll subtract the 18x from the right, bring it to the left. 8x minus 18x is negative 10x. I'm now going to bring my constant terms to the right side by adding 20 to both sides. So negative 10x is equal to 68. And then I'm going to divide both sides by negative 10. So x is going to be equal to negative 68 over 10, which if you wanted to simplify is equal to negative 6.8. Just dividing by 10 will just move the decimal. If you're ever not sure about your answer, you could always plug your answer, your final answer, back into the original equation, just to double check that it's true. So if you were to just take negative 6.8 and plug it in for x over here, plug it in for x over here, you should get the same thing. I'm not going to do that here, but just take my word for it. That's kind of just a good way to check your answer. All right, so some general guidelines for solving equations. Like I said, there's like a bunch of different ways you could go about doing it, and so it's not really useful to say like do this step, then do this step, then do this step, and that'll work every time. I don't think that's a useful way to think about it, but these are some good rough guidelines that you can do. So if there are fractions in your equation, you can clear them out by either like cross multiplying or multiplying by the least common multiple of any denominators. Oh, I probably could have shown you that. So, yeah, let me actually show you that real quick. So in our first step back here, we found where we decided to clear out the denominators by just cross multiplying. You could have just multiplied both sides by just any multiple of 6 and 4. So the least common multiple of 6 and 4 is equal to 12. So I could just multiply both sides of that equation. 2x minus 5 over 6 equals 3x plus 8 over 4. Multiply both sides of the equation by 12, that least common multiple. Now if you do that, the 12 cancels with the 6 and you're left with a 2. Now I multiply the 2 by everything. I get 4x minus 10 on the left, and on the right, 12 over 4 is 3. And I get 3 times 3x is 9x, 3 times 8 is 24. Now I can just kind of proceed as normally. Oh, I forgot an x over here, sorry. So yeah, 2 times 2x would be 4x, and then minus 2 times 5 is negative 10. Okay, now 9x, let's bring that to the left, subtract 9x. By the way, sometimes you'll see people do multiple steps at once. So I'm subtracting 9x on both sides, and I'm also going to add 10 on both sides. And that's totally valid to do that, just to sort of shorten up what's going on. So I'll get negative 5x on the right side, and on the left side. And on the right side, I'll get 34. So then x would be equal to 34 over negative 5, which is the same. So if you wanted this to be a decimal, you could make it so that it's a fraction out of 10, and all of a sudden you can see that this is the same answer that we got before. Okay, so anyway, so you can clear out fractions by multiplying by least common multiple, or by cross multiplying, however you want to do that. You're generally going to want to bring all the constant terms to one side of the equation by just adding or subtracting them. You'll want to bring all the variable terms to one side of the equation by adding or subtracting. And then once you do that, then you're going to have at this point something like I don't know, 6x is equal to 24. And then if you get to this point, then what you're going to want to do is just divide both sides by whatever the coefficient of the variable term is. By the way, I don't think I defined coefficient earlier. This is the coefficient. So 6 is the coefficient of the variable term. So the variable term is 6x, and the coefficient is 6. So just divide both sides of this equation by 6, and then you can see that x is equal to 24 divided by 6, which equals 4. Okay. Example 3. All right, so this is more of like an application. So let's say that the population P of a very small town 2 years after 2022 is given by P equals 200 plus 3T. Okay, so if I were to plug in T equals 0, then that would give me P equals 200. P equals 200 plus like 3 times 0 is equal to 200. So that tells me that the population after 0 years is 200. If I want to know what is the population after 5 years, I can use this equation or formula to figure that out. And then I can also use this to decide in which year will the population reach 300. So after 5 years, the population is given by P equals 300 plus, well, this is just telling us that T is equal to 5. So I just replace T with the number 5. So we're just basically picking a value for our variable. So this is 300 plus 3 times 5 is 15. So the population would be 315 people. Good to have units here. Okay, In what year will the population reach 300? So we're basically saying that if P is equal to 300, okay, so it's not, this is what I'm about to write is technically not true, but it's close enough to what we're looking for. If we're saying that P is 300, we basically need to know what is T, like after how many years does the population reach 300. Okay, this is like subtly not exactly the right thing that we need to answer this question, but I'll get to that in a second, but this is good enough for now. So for P equals 200 plus 3T, we just want to replace P with 300 and then solve for T. So let's subtract 200 on both sides. We get 100 is equal to 3T, and then divide both sides by 3. So then T would be equal to 100 over 3, which is like 33.3 repeating. Okay, so we're asking like in what, so we're not asking after how many years does this happen, we're asking in which year does the population reach 300? In which year will this happen? And so T is the number of years after 2022. So this is saying that after 33 and a third of a year, so like sometime in like April probably, the population would reach 300. So the population reaches 300 in the year 20. So now I just have to add 33 to 22, which would be 55. So 2055. And you don't want to say, you don't want to add like, you don't want to say like 2055.3 repeating, because we don't count years like that. Like obviously, like we would just say, well, it happens like a third of the way through this year, so it happens at some point during this year. Okay. Yeah. Also like it's good to think like, okay, well, if T was equal to just like a half, then that would mean like half a year after 2022 started, then it would still be in 2022, right? So just good to kind of think of it like that. All right, so 2055 is our answer. I'll let you try this last one. Wait. Oh no, there's two more actually. So I'll do this one and then I'll let you do the last one. So in this one, we'll actually have to set up an equation. So let's say that Michael bought Jody an $850 Secret Santa gift. This included a $500 tungsten cube as well as a bunch of $7 picture frames. How many picture frames did Michael buy for Jody? All right, so we're gonna set up an equation. We're gonna say, so we need to do a couple things. So first thing that we need to do is set up some variables here. So let's say that, so the two variables in this equation are going to be the cost of, like how much did Michael pay for Jody's gift, and F is going to be the number of picture frames that he bought. So C is going to represent the total purchase cost, and F is going to be the number of picture frames bought. So we can say what the total cost of the purchase is going to be. So it starts off with like $500 flat, like he just bought like a single one of these cubes. And then if he's buying a bunch of picture frames at $7 per picture frame, that price is going to increase by $7 for every picture frame. So if there's 2 picture frames, it'll be going up by 7 times 2. If there's 10 picture frames, it'll go up by 7 times 10. And if there's F picture frames, it'll go up by 7 times F. So this would be an equation that we can set up to solve this problem. So Michael bought $850 worth of cube plus picture frames. So that's telling us that C is 850, and we want to know what would F be. Okay, so we'll replace C with 850, and then we're going to solve for F. So we can subtract 500 on both sides. So subtract 500. We get 350 on the left and 7F on the right. And then we just need to divide by 7. 350 divided by 7 is just 50. So that would tell us that Michael bought 50 picture frames. Okay. Yeah, all right, so I'll let you try this one now. So the cost of ordering pizza is $12 per pizza, as well as a flat $20 delivery fee. And just to make the problem simpler, we're gonna just like include the tip in this delivery fee as well. So just, ignore tax, ignore tip, all that stuff. Just, it's $12 for pizza plus a $20 flat fee. How much does it cost to order 5 pizzas? And additionally, how many pizzas can you buy with $100? So I'll briefly say, you don't technically always need to set up an equation just to solve these problems. You could just kind of go right ahead sometimes and say, well, you have $850 is equal to 500 plus 7 times the number of picture frames. You don't really need a variable for the total purchase cost, but it is more useful in later concepts to be able to build these equations from the start and define all of your variables at the start anyway. And so it's a good habit to kind of be in when you're learning, especially when you're learning this stuff, so that it kind of allows you the flexibility to kind of be able to do more things later on. So anyway, try this problem, pause the video, come back when you're ready, and then we'll go over. All right, so I'm going to say that C is going to be the cost of the order. I'm going to make P be the number of pizzas that you're going to buy. Then the cost of the order is going to be, well, there's a $20 flat fee plus it's $12 per pizza, and we're buying P of them, so it would be 12 times P additional dollars. So this equation relates the two variables that we just defined, the cost of the order and the number of pizzas bought. So now we can just say that if we're ordering 5 pizzas, so in other words, if P is equal to 5, then C is equal to 20 plus 12 times 5, which is equal to 20 plus 60, which is equal to 80. Right. Okay. Yeah. Okay, cool. And I should put some units on this, so it costs $80. All right. And then for the second part, so if we have $100 to spend, then we can say 100 is equal to 20 plus 12p, and then solve for p. So we'll subtract 20 on both sides, get 80 is equal to 12p, and then divide both sides by 12, and then get P is equal to 80 divided by 12. What is 80 divided by 12? You could just list multiples if you want. 36, 48, 60, 72, 84. So it would be, what is that, 6 with some remainder. Yeah, so 6 with like a remainder of $4 left over. 1, 2, 3, 4, 5, 6. Yeah. Wait. Remainder would be 8. Yeah. So I think if I wanted to write this as a fraction, this would be like, or a decimal, this would be like 6 2/3. But anyway, the fraction here does not really matter at all. What does matter is that this is not a whole number, and we can't buy fractions of pizzas, right? So we only have $100, so we can only buy up to 6 2/3 of a pizza, but we can't afford that 7th pizza because that would bring us up to $84, which is $84 plus the $20 delivery fee, which would bring us up to $104. So that's too much, so we can only afford to buy 6 pizzas. Okay, cool. Yeah, so I think that's it for this video. Thank you for listening, and I'll see you in the next one.